So in 44, on page 523, we want to solve a trig equation. Tangent 4 to the fourth of theta minus 13. Tangent square theta and plus 36 equals 0. Yes, is that the one?
Yeah.
Okay, so of course we can get very sophisticated, and if you look at this equation, you will say, oh, I remember something we did in chapter 1 that is applicable here. And what am I referring to? Quadratic in form. Awesome. See, all this knowledge is not wasted, and it's not, it's always coming back. So I will say then, let's say y be tangent squared. Very good. So then we have y squared minus 13y plus 36 equals 0. What do I do to this? We just started. This is the first problem of the day.
Find the solutions for y.
Right. So I see that this is not difficult to factor. The product is 36 and the sum is negative 13. Very good. So there are two options. So there are two options for y. That's okay. Y equals. It's always the case. We get to step 25 and we forget step 2.
Yeah.
It's possible. So then we have two options for y.
4 and 9.
4 and 9. Very good. So then I go back now. So this first equation that says y equals 4 really means what? Indeed. Tangent square theta equals 4. Very good. And the other equation, and I will be back to it. I will come back to it. So what is the other equation that I have to solve?
Tangent square theta equals 9.
Equals 9. So from here then, tangent theta equals
2, 3.
I should have asked from the beginning. What is the degree in tangent?
4.
So how many solutions for tangent do I have to find?
4.
Okay.
So 2.
Yes. When we take the square root, right? Or you can move 4 and then factor out. I mean, completely factor tangent squared minus 4. And the other one will give us tangent theta equals plus or minus 3. Very good. So now I have to analyze each and every situation. The first situation is tangent theta equals 2. Okay? I have no knowledge of tangent theta equals 2. I can determine the square root of 2 over 2 over the square root of 2 over 2. I can determine 1/2 over the square root of 3 over 2. And I can determine the square root of 3 over 2 over 1/2. 2 is unknown to me. No problem. So I know where tangent is positive in the third. So there are two options for theta. Yes, they can be condensed and so on and so forth. And obviously plus pi k, where k is an integer, dot, 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 3 dots exactly. And now I have to find the angle whose tangent is 2. What do I have to do to both sides of this equation to determine theta? Of course, I have to apply tangent inverse to both sides. I'll go to the graphing calculator. I'll plug it in. Make sure that, depending on what you want the answer to be in degrees or you want the answer to be in radians. If you want degrees, then go back and check in the mode and make sure it's in degrees.
Does it matter?
No.
Oh.
depending on what the problem says, but the problem says solve.
Right.
It's up to you, whatever it's easier for you. So let's say in degrees. Degrees are, no matter what now, if you remember, we know that 1 radian is approximately 57 degrees.
Mm-hmm.
So if I get 2 radians, I'll multiply by 57 degrees to get my head around it, right? To make sense of it. Because if you say 2 radians, oh, it's roughly 120 degrees. Makes more sense.
Yeah.
Okay. However, remember in calculus, you cannot even talk about degrees. Everything is in radians. All presentations, everything, radians. Okay, so then I go to second and tangent inverse. I put 2 in it, close the parenthesis, or not. I always have to do that. So I get 63 degrees. Allow me to round, or if you want to be exact, you can put exact. So I'll put an approximation symbol and say this is approximately 63 degrees. We know it makes a lot of difference. So you want 2 decimals, or we can put 2 decimals, whatever you want to round up to.
2 decimals.
2 decimals, very good. So I'm going to write 0.43 degrees. Now, if we write degrees here, I can no longer put pi. So I have to write 180K. I cannot have degrees for the angle and pi for going around the circle. Okay, so I have to replace that by 180K.
So if we did radians,
Then you can leave it as pi.
1.107, we just put like 1.11.
That's it.
Oh, okay.
Plus pi k.
So what exactly is like pi k? Like would indicate the
Okay.
purpose.
Okay. If k is 0,
Yeah.
so the angle is 63 degrees. So this is the angle. Okay. So this is 63. This is the angle, correct? If k is 0, then it's this angle. If k is 1, then I land here. And this will have the same tangent. If k is 2, then I will have this. Another coterminal angle with the initial one. If k is 3, then I have 1, 2, 3, and I land here. So it's the other one. The pi k says, first of all, pi is the period of tangent. If the equation were in sine and cosine, I would have written 2 pi, because the period of sine and cosine is 2 pi. But it's pi because this is tangent. So it shows that there are infinitely many angles, not just one. Not just this one that ends in the first quadrant. They will always, all of them will be coterminal. They will all start here and end here. But I can create infinitely many solutions. So one solution is 63, the other one is 63 pi plus 180. The other solution is 63 plus 360. The other one is 63 plus 3 times 180. And so on and so forth. It just shows there are infinitely many solutions. Although one ends here and the other one ends here. One other thing for this equation is, remember, like we did last time, cosine theta cannot be 0. So whatever solutions we accept, we have to make sure that cosine theta is not 0. Why? Because this is a function, tangent is a function that has restrictions. Again, if the equation were in sine and cosine, I would have not written any restriction. Sine and cosine don't have vertical asymptotes. Okay, now how do I determine the other one? Well, obviously they have to have the same reference angle. So this piece must equal this piece. So what will be the other angle?
180 minus 63.
Y minus. So this is 180, and then I have to continue with 63.
Yeah.
So this angle must be 180 plus 63.43. And I get what? 143.43. And even this one has infinitely many options, because there are infinitely many coterminal angles with this one.
You need 243.
With one, oh, of course, I'm sorry. I didn't add all the way. Very good, of course. So it's 180 plus 63. Thank you. My mistake. So,
What about tangent theta equals -2?
oh, I haven't finished. This is just
Oh.
1.
Okay.
Then I have to go to -2, and then I have to go to +3, and I have to go to -3. All of them.
Okay.
Of course, cosine for any of these is not going to be 0.
So isn't 243.43 degrees, isn't that covered in the first
Yeah.
solution?
Yes, if you remember, we said for tangent, you can condense them into one solution.
Yeah.
So, yes. So if you write this, is
Yeah.
good enough because these are included in there.
Yeah, and you just write the k equals 0 plus 1 plus
Yes, I have to write that. This,
Okay.
yes, you either write k is an integer, which that's what it means, or you write 0, comma, plus or minus 1, plus or minus 2, comma, and 3 dots.
Okay. Gotcha.
That's a little bit more sophisticated way, or you just say k is an integer. Yes, these two can be condensed into this one. Good. So let's do one of these of the negative ones, because 2 is the same with 3.
Yeah.
It's not going to be anything different. So choose one with a negative.
The -3.
The -3. So we have tangent theta equals -3. I go to the unit circle. I have to find the quadrants where tangent is negative. And the quadrants where tangent is negative are,
24.
very good. Good?
Apply tangent inverse.
Yes, I will apply tangent inverse basically to 3, not to -3.
What's that?
In a moment, you'll see why and how. So tangent inverse applied to 3. And I get 71.57. So theta equals 71.57 degrees, which means, yes, which means if this is 3060,
You said you found tangent inverse of 3 first?
yes,
Positive.
yes. So this is the reference angle that I'm interested in, which is 71.57 degrees. Of course, it will continue, and this will be the other reference angle of 71.57 degrees. I know that the angle I'm looking for must have a terminal side in the second quadrant. And the other angle, which I know it can be condensed, but I like to present it, has to have a terminal side in the fourth quadrant. Both angles have to have a reference angle of 71.57 degrees. No question about it. Okay, so then I have a theta and another theta. And yes, plus 180k, plus 180k. And k, you don't have to write it twice. Once you write it once, it's valid for the entire problem. So what would you say is the first angle? It has to be standard angle. It has to start on the x-axis, and it has to end in the second quadrant. And it has to have a reference angle of 71.57.
So 180 minus 70.
Exactly. How much is that?
108 point.
Yes, this is the angle. Say it again, 108.
0.43 degrees. Yeah.
Good, and this is 180 degrees. Good. What about the other one? The other one must start at the same point,
288.43 degrees.
but it has to end in the fourth quadrant. Yes, so I have to go backwards. 360 minus 57. Is that clear? 2. Yes.
Can you go through that process again? So you found tangent inverse of 3, and that's the reference angle?
See, sure. Because if you remember, the reference angle is always the acute angle formed between the x-axis and the terminal side. Not the obtuse angle between the terminal side and the x-axis, but the acute angle. And that is always a positive angle. The reference angle, no matter where around the circle, the reference angle is a positive angle. So once I determined that this is 71.57, and I knew that the angle has the initial side on the x-axis and the terminal side in the second quadrant because the sign is negative, then I knew that the angle I'm looking for must be 180 short 71.57. Since they are opposite angles, right? And they have to have the same reference angle, otherwise tangent is not going to be the same. Only angles that have the same reference angle will have, like in this case. Yes, right? So now I know that this must be 71.57, and it has to be a positive angle. So now I'm going backwards from 360 back 71.57. I'm curious, since you asked, I'm curious what the calculator will give if I did put tangent inverse of -3.
Gives you negative 71.5. So
Right. It's not a mistake, because obviously this angle is the same with the angle -71.57. So it's not a mistake because this angle is identical with the angle -71.5.
positive.
Right, but we prefer positive angles. Now the problem is, how will I get the other one? That is the problem that I run into if I consider the negative angle. How will I find the 108?
180 minus 71.
Right. So negative 180 minus 71.57, because I have to get back here. Negative 71 and minus 180.
Yeah.
So I think it's easier to think in terms of positive angles and the reference angle, which is always a positive number.
Yeah.
It's up to you. Good. Is this good enough? Okay. Other questions? Anything else that you worked on? Anything else that you would like to go back to? Other questions? If not, I would like to wrap this up with more problems, more trig equations from the last section.
Okay.
But if you have something that you would like to review, let's review it first. Anything for the test that you would like to ask? Are we okay with the test? Okay.
Just a quick reminder.
Yes, please.
Is it available until Friday or until Saturday?
I think I put it till Friday.
Just double check. Last time it was Saturday.
That's what I think that's what we talked about. But do you need it to take it on Saturday?
No, I'm just asking.
No, because
Just
if you
make
need
sure.
it, I could change it. I mean, that's not a big deal. But I have to let them know.
Okay.
So if you consider taking it on Saturday, you have to let me know so I can check, because you may go there and I'm in class and they'll call me and they will not find me, and
Right.
so let me know. Before you go, let me know so I can let them know. There is a protocol. I have to fill out a form.
Right.
I have to give them the roster and so on and so forth. So please let me know. Don't forget. You either text me or you call me, or yes, Nico?
I'm on the roster this time.
Yes, you are. Yes. I made it the case to put your...
You weren't on it before.
No, because he registered late and I sent him the previous roster and he wasn't there and he was having a heart attack.
I said I was going to take it on the weekend, but then I was like, oh, well, Friday.
And then Will was a good friend of mine. He said, I'm not going to put it. I said, please. Yeah, Yeah. He calls me and I said, tell him to go home. Don't put him on the roster. So yeah, no, you are this time. Okay, so let's continue and finish up 7.4. A 7 at 5, well, the same trig equations, but they are more sophisticated. So let's look at the other require. What about your classwork? Did you finish it? Yeah, I got it. Because I wanted to discuss this with you for a moment, and I wanted to show you, and Ariba already showed me that he discovered the idea. It's good practice, although we are not really rationalizing anything. There is no radical in there. It's a good practice to multiply and divide by sine x plus cosine x. I don't know if you determine it in a different way or show it in a different way, but that's what I was recommending.
I didn't do that.
But you got it. There are other ways, of course. So if are you done with it? Did you prove it?
Yeah.
Okay, so I would like to show you that other method. Let's see how you showed it. So you change. Oh, yeah, that's good too. So you replaced 1, so you start on the right hand side. I see.
Yeah.
Perfect.
Yeah, I think I did the same thing.
Yeah, perfect.
I tried it a couple ways at first, I was having
Yeah.
issues, and then I replaced
Yeah.
one, and it was easy.
Well, it took me a while because
Yeah.
I saw the 1 and then I saw the denominator and I was like, okay, well that's the agreement. And then yeah, factors.
Yeah.
And then
So here-
oh, okay, that's
Here is a technique that is important to look at and remember. So sine x minus cosine x, that was the problem. Okay, so I didn't copy the right-hand side, so I'm starting with the left-hand side. So because maybe I should write the right-hand side as well. Yeah, let me write it. Yes. Let's write it. So it's 1 plus 2 sine x cosine x divided by 1 minus 2 cosine squared x. So what you did is perfect. You replaced 1 by sine squared plus cosine squared. That's a very good technique. But what I was going to show is that the left-hand side, sine x plus cosine x, depending what we need to do and what is the outcome that we are looking for. So we can multiply and divide by sine x plus cosine x and sine x plus cosine x. This is what I did when I wrote the solutions. As you notice, it looks like rationalizing, but we're not rationalizing anything because there is no radical here. This is a widely used technique. Now, you could say, wait a minute, how did you pick the plus?
Right.
Why didn't you pick the minus? Because I looked here. If I had picked the minus, I would have had difficulty, yes. So when I multiply a minus b times a plus b, I get sine squared minus cosine squared. And this is very similar to cosine twice alpha, just reversed. That's why I chose the plus. And the numerator, it's sine x plus cosine x squared. I'm using the special product. First term squared, sine squared, plus 2 times the first times the second, sine x cosine x, plus the second term squared. And of course, we get the same thing you did. Sine squared plus cosine squared is 1. I replace sine squared by 1 minus cosine squared, and I get 1 minus 2 cosine squared x, which is the right-hand side. So the exact same thing. Any questions? So sine squared plus cosine squared is 1. I copy 2 sine x cosine x. And I change sine squared into 1 minus cosine squared. 1 minus cosine squared minus cosine squared is 1 minus 2 cosine squared. and this is the right hand side. Is it okay? But it's basically the same thing you did. But just keep this in mind. I will not use something like this for tangent, cotangent, something.
Right.
But sine, cosine,
Because I was looking at it in the terms of like talking about some different identities. Versus
Yes.
manipulating the equation.
right, but yes, that's true. However, when I wrote this, we did not know the half angle and the double angle identities.
Right. Yeah, but I didn't use that. I used just sine squared plus cosine.
That's fine. That's perfect. I just want you to see something different.
Yeah, no, it's good to see it.
Okay, 7.5. So let's look at more sophisticated trig equations. And let's choose on page 528 from 3 through 16. 3 through 16, 528. Anyone? Or I will.
Maybe we should make the first one.
I should?
Yeah.
Okay. I am going to pick the first one. I'm going to pick the first one. I'm going to pick the first one, number 8. And 3 sine twice theta minus 2 sine theta equals 0.
Oh yeah, quick question. So
Yes.
which ones do we have to remember? Which ones are going to give?
The identities. Okay. What you will be given are the product to sum and sum to product.
Okay.
Those will be
What about
given to you.
doubling or halving?
I'm sorry.
What about doubling or halving?
No, you have to remember the lowering the powers, and you have to remember the half angle and double angle
Is this for the next test or
for the
final?
next
Whatever.
test and the final.
I'm just asking just to.
Yeah.
Yes, I will write them down for you again and again. Yes, I will give. If you know, we were going to start, but we didn't. I only started with Joey and Arib, so I didn't. I went directly to Joey's question. I didn't write the identities. I was going to do that first.
Okay.
Yeah, sorry about that.
No problem.
Good. So let's look at this, and let's think of a possibility. As I mentioned before, you may or may not have the whole path in mind when you look at an equation or an identity. You may not, but you have to start with something. Something should come to our minds. What do you think? Where will be the starting point? Where will you look? Of course. I can't do anything to 3. I can't do anything to 2 sine theta. I can't do anything to 0. That's my only chance. So then 3 times 2 is 6. Sine theta, cosine theta minus 2 sine theta equals 0.
Does sine.
Oh, yeah, yeah,
Those
oh.
2 sine.
Yeah, yeah. Well,
Okay, 3 times.
yeah. I mean, I get it. It's just I like to write them all.
You should, it's till you get used to them. I completely agree. So we used, for this, we used 2 sine theta, cosine theta. That's the identity we discussed last time. Is that okay? Good. So now it's all plain and simple. Any suggestions?
Factor out
Yes?
sine theta.
Very good. And what is left in parentheses?
3 cosine theta minus 1.
Very good. I will divide both sides by 2 because I don't want you to write that 2 could be 0. So there are 2 options here. What is the first option?
Sine theta equals 0.
And cosine theta equals?
1/3.
Very good. I have a lot of knowledge about the first one, but the second one I know nothing of. Good. So how do I continue? I go to sine theta equals 0. I go around the unit circle, and I know where sine is 0. Sine is 0.
Pi.
Yes.
2 pi.
Yes, or 0,
or 0.
which is the same thing. So there are two possibilities, theta equals and theta equals. 0 plus 2 pi k, where k is an integer. And the other option is
180.
yes, that's if we stick with pi, then we, yeah, but you're right, plus 2 pi k. Yes,
So
even
that's
those,
right.
I'm sorry,
That's right. Oh,
it's 0. No, you don't have to, but I have to show where it's coming from.
okay. I mean, well, if we're solving
But because your period's 2 pi, you need both.
what I'm saying is not
No, he's at
one not included in the first
only if you use pi k. You have to be careful.
one. Okay.
If you want to condense them, no, with 2 pi it's not going to work. If you want to condense these two, you will have to write pi k. In order to get these, you have to write pi k. Otherwise, you will only get that.
Are you saying that's a valid answer then, if you write 0 plus pi k?
Yes,
Oh, okay.
but you will not write the second one if you want to condense them.
Yeah, oh, I see. Okay.
If you want to condense them. There is no need, unless you want to. It's fine. Good. So cosine theta equals 1/3. Where is cosine positive?
1 and 4.
1 and 4. Very good. So cosine 1/3 will be something like this. This is 1/3, from 0 to 1/3, correct? This piece.
Right.
Yeah.
Because this is 1, I divide it up into 3 equal parts. So there are two angles. One that ends here, and the other one that ends here, whose cosine is 1/3. So I have to find the reference angle, which will be the same in both, and then figure out an angle in the first quadrant and an angle in the fourth quadrant. So I will apply cosine inverse to what? Second and cosine inverse to 1 divided by 3.
Yeah.
And I get 70.53. So 70.53 degrees. Although I started here with pi, I should, it's not equal here. Is that what you were asking? I meant positive. Is that what you were asking?
No.
Oh, okay, good. You haven't noticed that mistake. Okay, I'm sorry. I didn't mean the equal symbol. I meant plus.
Now I know this.
Okay, thank you. So then cosine theta equals 1/3 gives us two options, theta to b and theta to b, and plus 180 degrees times k. I'm sorry, 360, of course. Because I have found the answer in degrees, that's why. And 360k. So this is 70.53 degrees plus 360k. And the other one, say it again.
Well, I was saying, I feel like we should not do that. I mean, we just did sine and radians, and then we switched to degrees.
Because my calculator was in degrees. Well, I can change this one. So theta equals 360k, and theta equals 180 plus 360 degrees k. And you can go back and change both of them in radians later, whenever you want. So what is the other one?
289.47. So 360 minus 70.53.
Yes, 360 minus 70.53.
So 289.47.
Very good. Good. Let's continue with anything you want from 17 through 34. So you can go back and change all of them in radians.
Yes, I feel like it's
Yes, we should not have both.
Yeah.
Oh yes, absolutely. I completely agree. Good. Anything you'd like to pick, or I will?